All right, graphing with slope-intercept form. Slope-intercept form resembles y equals mx plus b. Y equals mx plus b. This m is our slope, and this b is our y-intercept. This y equals mx plus b, so we have y equals m times our slope, x equals or plus b, our y-intercept, y equals mx plus b. Now, to graph, there's 4 steps that we need to follow. The first step is to make sure that, if necessary, we arrange the equation into slope-intercept. So we're going to use this equation y equals 2x plus 6 for an example. Does y equals 2x plus 6 resemble y equals mx plus b? Yes, it does. We arrange the equation of slope-intercept. Check. Step 2, we plot the y-intercept. So if we're going to use y equals 2x plus 6, we got to use our graph paper. What's our y-intercept? That's b, so that's 6. So our y-intercept is plus 6. 1, 2, 1, 2, 3, 4, 5, 6. There's plotting our y-intercept. 3, we take slope as ratio and move, rise over run. So here our slope is 2 over 1. So I'm going to move 2 over 1, rise 2, up 1, or over 1, rise 2, run 1, and keep going. Or I could fall 2 and go back 1 all the way through here. Plot a couple of them. And then 3, connect through the points. Don't just stop at the 2 endpoints that you do. Really make a conscious effort to take these points and go all the way through. Use the whole big graph and draw your line. And then remember, I like y equals 2x plus 6. So there's the graph of our line. So if it asked us to write a linear equation if the slope is 3/4 and the y-intercept is -2, well, so if our slope m is 3/4 and our y-intercept b is -2, if we think y equals mx plus b, we're going to plug in y equals 3/4 x minus 2. Great, there's our linear equation. We're going to graph it. So I'm going to go to -2. We're going to graph y equals 3/4 x minus 2. When you go to -2, it's in slope-intercept form. Sorry, you can't see. Y equals 3/4 x minus 2. We're in slope-intercept form, so I'm going to go to my y-intercept -2 and move my rise over run. So rise 1, 2, 3, run 1, 2, 3, 4. Rise 1, 2, 3, run 1, 2, 3, 4. Or I could fall 1, 2, 3 and go back 1, 2, 3, 4. There's enough, I'd say. I'd like at least 3. And then I'd take my line and I connect through the points, make a nice big graph, y equals 3/4 x minus 2. So now, if we have to graph 3x minus 4y equals 12, 3x minus 4y equals 12, first thing we need to make sure it's in slope-intercept form. It's not quite. Remember, slope-intercept form looks y equals mx plus b. So I want to take this and I want to get y by itself, so I'm going to subtract 3x on both sides. So now I have -4y equals -3x plus 12. I'm going to then divide everything by -4 and get y equals now a positive 3/4 x minus 3. And there now is my graph in slope-intercept form. So I can take and I can start at -3, and I'm going to move up 3 over 4, up 3 over 4, or I could have gone down 3 and back 4, and I could have connected the dots going through and say y equals 3/4 x minus 3. Y equals 3/4 x minus 3. And there's that. Oh, look, these two lines are parallel. We'll get there later. So, Couple lines to be cautious of. If you have something that it were to say maybe y equals 4. Y equals 4. Now that is in slope-intercept form. If you think y equals mx plus b is your slope-intercept form, it's just what's m? M happens to be 0. So if we had y equals 4, we'd go up to 1, 2, 3, 4. 4 is our y-intercept, and we have a slope of 0. So we're just going to go horizontally across, and we have that y equals 4. So for example, let's say if we had y equals negative 7, we went negative 1, 2, 3, 4, 5, 6, 7, negative 7, slope of 0, y equals negative 7 right there. Now, if we had a line, this one's not quite in slope-intercept form. Let's say we had a line that said x equals negative 5. What we're going to do here is we're going to go to x equals negative 5, 1, 2, 3, 4, 5, and we're going to plot a vertical line straight up and down. What is this slope? If it's straight up and down, it is an undefined slope, and this is x equals negative 5. Let's say if we had x equals 6, we would go to 1, 2, 3, 4, 5, 6 right there, and go straight up and down, labeling it x equals 6. Alright, couple of things. Now, let's look at identifying the slope in y-intercept form from a graph. Remember, we need our slope and our y-intercept. Let's look at the easier one first, our y-intercept. So if we have this graph, where does it cross the y-intercept? Looks like it crosses right about here. And what's that? It looks like b equals 1 for that. Great, we have something. Now we need a slope. Let's see, we have a nice even point here. So let's use our rise over run. We rise negative 1, and we run 1, 2, 3, 3. So we have a slope of negative 1/3, a y-intercept of 1. So we could say that this equation is y equals negative 1/3 x plus 1. We found our y-intercept of 1, we found our slope of negative 1/3, and we went from there. And we plugged it into y equals mx plus b to give us this equation of a line. Now, when it comes to our homework, our practice problems, we are on page 560, number 18 through 36, multiples of 3. 18 through 36, multiples of 3. I should see, I believe, 6 graphs on graph paper. Now, here's a reward for listening to the end of the video. If it's not on graph paper, I'm not accepting it tomorrow. No graph paper equals no credit. No exceptions. Do it on graph paper, please.